Welcome to the Mining Pulse, checking the heartbeat of African mining. Every week we gather the specialists, run the diagnostics, and give you the market intelligence you need. What's running hot? What's flatlining? What are the vital signs telling us?
Today we're joined by Charles Deakin, a chartered mining engineer. He spent his career turning underperforming blast systems into disciplined, data-driven operations that deliver real gains in fragmentation, cost, and safety. So Charles, welcome to the Mining Pulse.
Good morning. Thank you very much for having me.
Absolute pleasure. So this episode for me is quite exciting. When I read drilling and blasting, it took me back to my childhood of, and I won't say I actually did it, but blowing up stuff.
And every mining engineer's dream.
Yeah.
Exactly. So maybe just a little on you. I mean, was it an extension of a childhood that got you into this?
Well, yes and no. I'm from the UK. My father was a mining engineer by trade. I studied mining engineering, and I came out to South Africa in the early 90s with one of the large mining houses to work as a mining engineer on one of the gold mines near Carltonville. And it was that time spent underground where I got up close and personal with blasting and explosives and understood what they can do, the technical aspect behind them. The results of using them are immediately visible, which is nice.
It's rewarding.
Yeah, it's rewarding to be able to see the results of your work immediately, and that's what really got me interested in that particular aspect of mining. My contract with that mining group finished after 2 years, and shortly thereafter I picked up a role with one of the major explosives companies here in South Africa. So that's how come I got into it. It was, I guess, almost by design, almost by accident.
What particular, if you can think back that far, not that you're that old.
Thank you.
But what particular, besides your dad being a mining engineer, what was it about the mining industry that made you think, I'm going to study this?
I think that the mining industry is very broad. Academically, it's very broad. It covers all aspects of engineering, mechanical, electrical, civil, all sorts, and none in any huge amount of depth. So you become a jack of all trades, master of none, if you like. And of course, with the mining engineering qualification and lack of any mining in the UK, it was a natural opportunity to travel and go and explore. Yeah, and as I say, I came out here straight from university at the age of 21, and here I am, older.
31.
Yeah, there you go.
Great.
So obviously in doing some of the work for today is you consult specifically around blasting, and there's an international institute that actually sort of helps mines understand this better, provides information. Could you, what exactly is that, and what are they called, and how do you actually help operations in particular?
Look, so I have, through my practical experience working on the mines, an understanding of what the operations are looking for in terms of their value chain, but with having technical qualifications or academic qualifications and certifications through institutes of explosives engineers and the like, it allows one to put the science behind any recommendations, advisory, consultation to the mines, to the operations. So the academic married with the practical gives a greater level of credibility to the operations in terms of you're now discussing the technical aspects with a practical output and production understanding as to what your clients are possibly looking for. Does that answer your question?
Yeah.
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 Charles Graham and my parents watch this show,
Okay.
and our siblings,
Yeah.
who are not in the mining industry. So when they hear about drilling, they're probably thinking about exploration drilling.
Yes.
Putting down drill bits
Yeah.
hundreds of meters down into the crust and bringing the cores up or the broken bits of stuff up and analyzing them to see what you have underground. Can you tell people how that's different to drill and blasting?
So you will have a number of mining methods, which we won't get into detail, but primarily underground mining and surface mining. In both instances, you are really drilling. You're essentially drilling holes for the sole purpose of putting explosives into them, initiating those explosives, and fragmenting the ground, which is the first step in the rock processing process.
Yes.
So everything down the line from blasting, loading, hauling, crushing, processing, relies on the success of that drill of that initiation and rock breakage function.
Okay. So your drill and blasting is not to explore, it's to get a hole so that you can put a bit of explosives down there and break the rock so you can pull it out the ground and
Exactly.
put on a truck. Or
Exactly.
conveyor belt or
Get it to the plant so that the metal or the material can be recovered from that from that block. Yeah.
So it's obviously a dangerous activity, I would imagine.
It can be. Yeah. You'd like to think that regulations will mitigate those risks, but yes, there was always risk.
Inherently, it's dangerous
of
if you're
course.
lighting a piece of TNT.
Well,
or something.
exactly, yeah.
But then you don't have the guys with the
plungers.
box
No,
and the
not
plungers
anymore. But there are still the regulations and the procedures mitigate the risk. But as long as we follow those procedures, then the risk is minimised, but never. What's the word?
Eliminated.
Eliminated. Thank you. Yeah.
Okay.
And obviously, when it comes to the drilling, I mean, there's a proper science behind that. I mean, a certain diameter hole spaced a certain place. I mean, you said that everything happens downstream is essentially affected by what happens in this blast.
Yes.
So, I mean, how much science is actually going into the actual drilling of that hole, to what depth and charges and that kind of stuff?
Yeah, a significant amount of science or engineering goes into that process. Let's take surface mining as an example, because it's a little bit simpler to visualize. You will have a block of ground, and you will have a pattern of drill holes which will be spaced 4 or 5 meters apart, for argument's sake, and that spacing will be a function of the explosives that you're going to use and the required results that you want to get out. The depth of the hole also is a function of the mining engineering or the pit that you are operating in. So there's quite a lot of engineering behind this, mine scheduling, the mobile equipment that we're using, and then using all of those geometric inputs, we will then design our blast around that using the explosives available in order to give the required amount of energy at the right time, at the right place, to give the right result.
And how much of that is an established science? How much of that is a spreadsheet? When you give the right inputs, it'll tell you what the spacing needs to be, what the explosives you need to use, what drill depth you need to go to. How much of it is still an art?
Yeah,
because it does seem like a little bit of an art to me.
It's both. It is an art. There are a number of rules of thumb which an engineer can use to start off with. But rules of thumb are exactly what they are, rules of thumb. They don't solve every problem. And in an ideal situation, we will take our blast results and reconcile them against what did we want to achieve, what did we actually achieve, and then feed back those results into the engineering or the design phase, which will maybe give us the opportunity to fine-tune the rules of thumb that we had used into a better design for the next blast.
And is that very dependent on the actual rock type?
Yes. Yes.
I don't know what characteristics, physical characteristics of the ore body are important.
Well, the rock hardness is primarily one of them, but obviously specific gravity to a certain degree. There is a lot of you guys are in mining anyway, so you'll understand that each piece of ground is fractured, can be fractured, have dikes, have intrusions, etc. And then blasting engineers do have to rely on informational input from the geologists to be able to understand, okay, this piece of ground is ore, this piece of ground is waste, and we might treat each differently. Yeah.
Okay. Interesting. Because you may not want to break the waste up the same way as
you probably won't.
Right.
And if the waste and ore are well defined, they can be separated away from each other, so you can't. So you minimise the dilution. In some instances, it's not that easy.
Probably the most exciting sign for me on a mine, when I'm driving onto a mine, is if there's a sign that says blasting
today
at 4 o'clock.
Yeah, it's exciting for you. For the guy taking the blaster, it's probably the most nerve-wracking part of his job is when he's pushing that plunger, if you like, and waiting for the shot to happen or not to happen.
And nowadays you've got people with drones videoing it.
There you go. And the mine manager and all of his staff on the perimeter watching this shot. Yeah.
And from the coal industry, the guys used to explain to me that what you don't want in a blast is rock flying everywhere. You really just want it to lift nicely and be, but inevitably I've seen so many pieces of rock flying.
Yeah. Well, yes, I mean, that's an important point, is that Flyrock, which is the terminology for what you've just described, is inherently a wasted energy. Because the explosives are not doing what they're required to do, which is fracturing and fragmenting and moving. It's chucking stuff into the air. So a blast which you see with a lot of fly rock has not been well designed, or there are measures which you could take to mitigate that for the next shot, provided you implement the required feedback.
Needs to go back into the Excel spreadsheet.
Yeah, exactly.
Refine it.
Yeah.
The rule of thumb.
Yeah.
Well, what's a skew thumb like mine?
Yeah.
Well, in actual fact, again, it could be a function, it could be a technical function of an incorrect design, or it could be indicating that your on-bench controls, your QAQC controls, aren't as strict as they could or should be, and this might also give you more information about the on-bench activities and to whether they are really conforming to what you want the output to be.
Yeah. And you've just touched on QAQC.
Yeah.
In terms of like the challenges around blasting or drilling and blasting, where do the general challenges actually sit when it comes to this discipline on the mine?
I think the main challenge is the first challenge is always the drilling, and the positioning of the drill hole. Is the hole in the right place as per design? Is it the right length as per the design? And has there been any deviation in the drill string? So what happens at the toe, you might want to drill a vertical hole, but depending on your setup or the flexibility of your drill string, the drill bit at the toe of the hole may not necessarily be directly underneath the collar, which means that the explosives distribution or the energy distribution at the toe is not going to be what you expect, which can affect your your blast results significantly. Blast results then affect fragmentation, affect loading and hauling, etc., 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 etc. Then the next challenge will be the on-bench explosives loading, whether that's by hand or through machinery, and of course the people on the bench as well. Is the QAQC process well designed? Is it well managed? And is it well executed? Because again, if we're not measuring what's in the hole, we can't manage what we don't measure. And, that can result in a poor result. And then I think thirdly, the third challenge is how well do we reconcile the actual output versus the desired output? How well do we reconcile that back to the next blast and our decision making as to how to go around designing that? I think those are the biggest challenges, practical challenges.
Two aspects at least. One is the actual drilling.
Yeah.
And I suppose you call it surface mining.
Well, that's what
I need to change what I call it, because I used to call it open cast mining.
Yeah, open cast mining is
thing, right?
Within surface mining context, there are subcategories. There's open cast, open cut, quarrying. They're all similar.
And so those ones you're drilling vertical holes.
Vertical holes.
Assuming. And then underground you would be drilling a combination of horizontal and vertical.
Horizontal and vertical, but more often than not, vertical being up holes and
gosh.
How
does it stay in?
It was sticky explosives and plugs to keep them up the hole. So in the diamond mines in the Northern Cape, for instance, they'll perform a technique called ring blasting, and they will have up holes in a fan, pretty much like my fingers are like that, with up holes, long holes, 15, 20 meters in length, maybe longer.
Gee.
Load those holes.
How do you charge them? Little pieces of...
You charge the explosive through a hose.
Wow.
And pump the explosives through the hose.
It's a whole world.
That's a whole different kettle
of fish. And then when
it
breaks, it drops.
Exactly.
Instead of lifting.
Yes, exactly. Yeah. Look, it's a bit more. It's a bit more technical than that, but yes.
When you said the vertical hole, I just pictured a guy with a long stick with a piece of dynamite on there and pushing it up through a hole.
And then holding it there until it blows.
Yeah. So now on the narrow reef mines out there on the gold mines, those will predominantly be horizontal holes. Yeah.
Okay.
A lot shorter, maybe only 2 meters in length.
More frequent then.
Yeah, and you'll blast every day.
Okay.
If you can.
So there's the science and the art of the drilling, the pattern, which angles to drill at, and all these things. And then there's the actual explosives part. So remind me, who are the big explosives guys in South Africa or Africa? It's probably AACI or AEL.
Yeah, AEL.
Sasol?
Sasol, Sasol, as they used to be. NAX, the large South American company, purchased them a number of years ago. Maxam is here. BME, Orica.
Oh yes, of course.
Yeah, Orica.
Yes.
And then you have another couple. Solo is an Indian company. They're out here.
Okay.
It's quite possible I've missed one or two. Dino are poking around, and Austin is an American company also. So you've got 7 or 8.
And suppliers of explosives.
Suppliers of explosives, yeah.
And how involved are they with the mining guys, with the drill and blast guys at the customer face, in terms of consultation and helping tailor make something?
Yeah.
Are they very involved, or is it a generic product that you buy off the shelf and say, just give me another 200 of these?
Yes and no. Many explosives companies or many the business relationship between clients and explosives companies are predominantly contractual. Such that your explosives supplier may have a supply contract for 3 to 5 years.
It's a big cost.
Yeah. Of course, you've got capital equipment, you've got an infrastructure to put up on the mine, so it's not something you just deliver off the shelf normally. And in that contract, there may well be service provision. There might be tie up, load and shoot type of operation, where the explosives company is actually doing a lot of the job of what traditionally may have been done by the miners.
Interesting.
Some may even take the responsibility of firing the shot, and then by doing so, they take on the responsibility of the blast results as well.
Oh, yeah.
So, and then in some instances, there is some off-the-shelf purchasing, particularly where that contracted explosive supplier may not have enough stock on the shelf, particularly with initiators or detonators.
Right. And are there things that are interchangeable? Like, can you use someone else's detonator with somebody else's
Charge.
charge? And
You can. The more traditional detonators are very similar in how they operate, how they look. Some of the newer technologies, like electronic detonators, you can't mix and match because, like any piece of software and hardware, the hardware drives
They've got to talk to each other.
Yeah, they've got to talk to each other, and if you don't have the right protocols, then it's not going to work.
okay, interesting.
It got me thinking now. So, I mean, as an independent consultant in this sphere, I'm sure you've pretty much seen
All of it.
everything from world class to
Not so world class. Yeah.
I like the way you put that. As well as tier one mines and let's say startups. But if we went to the real junior guy who is using explosives and they are blasting, what kind of challenges are they having? And what should they be doing to become safer at what they do? Because anything that's going to blow up, I mean, there's a risk of
Yes,
death.
yes.
You know,
Yeah.
so what have you seen there that
When you say junior, do you mean it's a single mine
a single
company?
mine, yeah, a small,
Or you mean Zama?
that's a different leg.
Yeah.
They're also blasting, but we don't want to promote the latter. But
Look, any user of these products is obligated. That's not right, the word that I wanted to use, but they should conform to the regulations, and and most of the significant mining jurisdictions in the continent have their regulations. As I said, most of those operators should conform to them, but I think many of the regulations, in their own right, are thin. In various areas, they're not they're not consistent across jurisdictions. So, for instance, if you were a junior miner with an operation in Ghana, which is quite well regulated, and another operation in, let's say, Burkina Faso, for argument's sake, which might be less well regulated, the difference in regulations. There is variability in those regulations, and it requires those operators to understand if there are any variations and executing those variations. Yeah, but that's why those regulations are in place.
yeah, and who's policing them? And I use the word policing because but who's actually regulating this sphere? Because again, we've had numerous discussions, and there's some really amazing bodies out there that are doing phenomenal work to make it safer and easier and
Provide guidance
and all that. I mean, so who's actually doing that? Who's providing this guidance across the continent and obviously globally?
Yeah, look, across the continent, the regulatory bodies in country, like the Department of Mines, minerals and resources, depending on which country, and they would govern from a legal perspective the activities. And as I say, each country will have a different set of regulations. Some are thinner than others. I think as compared to, say, Australia or North America, whereby you have much more stringent regulations, and of course, let's use Australia as an example. As a jurisdiction, is probably as big as Africa in terms of the amount of minerals that they pull out of the ground, but they have one set of well-understood regulations.
in one language.
In one language, exactly. So we've got now English, French, Portuguese, Arabic, others, so it's, and we have
Chinese.
And maybe 25, maybe more countries in Africa with some significant mining. From a global perspective, there is institutions like the Society of Explosives Engineers are involved, but they're more from a technical perspective. I think a lot of operations in Africa look towards global best practice. Over and above the regulations, which tells you comply or don't comply, best practices tell you if this is what you want, this is how you should do it. So we do look towards Australia, towards North America, possibly towards Europe, for those global best practices, what they say in terms of the practical application of explosives rather than just legal compliance issues.
I imagine it would be overseen by the DMR in South Africa.
Well, yes. So exactly
they
right.
would come and do occasional audits and make sure that things are being done.
Yeah, they do, and particularly when there's. But I think I shouldn't use that word. But however, they are quite reactive. So the DMR will get involved when there's an incident.
Yeah.
Rather than proactively implement directives. Having said that, they have recently introduced a mandatory code of practice on all surface mines, specifically with regards environmental results of blasting. There'll be vibrations, air blast, and Flyrock. So all of the operations, all surface operations, including quarries, are now obligated to conform to this mandatory code of practice, which for some, particularly those, small entities, can be quite a significant undertaking. Whereas before they haven't. They've cruised by. Now all of a sudden there's a mandatory code of practice to conform to.
Which I think is a good thing. I mean, a lot of the mines that today, there's massive communities typically on the doorstep of mines.
Yes.
Tell us a bit about you and what you do. You provide almost a consultative function, is it?
Yeah, look,
you're not tied to any specific supplier of
No. So our role as Blast Management International, which is an Australian company, was founded over 20 years ago, to which I am affiliated, is a consultant or advisory entity which looks into your more traditional consulting, technical consulting, auditing, and also training.
Okay.
And in that package, the company has also developed its own drill and blast software.
Great.
So what does that mean? What do we actually do? What do I actually do here in Africa? We get involved, we being me, gets involved with a lot of auditing of operations, whether that's compliance auditing or productivity auditing. So we get involved with all aspects of the drill and blast value chain and where improvements can be made. We're not affiliated to any supplier. So we see the ins and outs of all of those 7 or 8 suppliers I mentioned earlier. We're not biased towards them, and we have no affiliation to any of them.
Great.
I'll be flying to Tanzania the week after next to do some work with a large gold operation, primarily on setting up a process and procedure for them to implement because they're starting to move very, very close to their processing plant.
Oh, right.
And of course, now they have to limit their vibrations so they don't disrupt the processing plant.
Break stuff.
Yeah. And in doing so, we're going to put together some blast designs for them to say, well, you can do this, but you can't do this, and you need to minimize the other. And these are the constraints that you need to put into place to ensure that your plant doesn't break.
Processing is the side that Graham and I get.
Oh, right. Yeah, yes.
Not. And I suppose there's 2 aspects when it comes to drill and blast. There's, the fragmentation is the thing that sometimes is suboptimal.
Yes.
And that could either mean too coarse or too fine.
Yes.
Right? Too coarse, I suppose the problem is it doesn't fit into chutes or into crushers or on conveyor belts or something. It's just too big, and that causes a huge productivity problem because now someone's got to break it again.
Yeah.
It's a big tombstone or table-sized
boulder
chunk. And someone's got to manually break it, or I don't know how they break it, or move it with a rock picker or something. So there's a too coarse side, which is an upfront problem and a production problem. And then there's the too fine side where for some processes you don't want the mineral to be too fine. because you lose.
Yes,
some of
exactly,
it.
yeah,
Coal industry is an example, and maybe iron ore and things like that. So why is it so hard to get it right? Is it people? Is it skills? Is it the tech? Is it the lack of geological understanding?
Well, it's all of them, and I think if we look at the bigger picture, and you will understand this coming from the mines, you have various departments on the mine: the drill and blast, load and haul, crushing, processing plant, and they've traditionally all worked in silos. So the drill and blast department
They don't talk to each other.
No, they don't talk to each other, and they're not really concerned about what happens down the line. So the drilling and blast department, for instance, might optimize its process in order to meet its KPIs, which are probably financial, which may not suit the KPIs of those. You know what I'm talking about.
Yeah, absolutely.
So.
Tons.
So that's issue number one. So that's when we want to talk about integrated management systems, whereby we want to bring all of these silos together and operate towards a common goal and that common goal would be a productivity KPI or a profitability KPI, whatever it might be.
Mine wide.
Yes, exactly.
Yes.
So back to your original question, and it all falls part of that integrated sort of process. Is you have the on-bench discipline, the QAQC, which we spoke about earlier. We have the engineering or the technical design aspect.
That's guys actually checking. Did you drill the hole as deep as you said you were going to drill it?
Yeah.
Did you drill it where you said you were going
exactly.
to drill it?
Did you do what?
Did you put an extra charge in every hole, or you miss a few?
Exactly. Okay. So the discipline on bench, and of course before that comes the adequacy of the design to meet the objectives. Is it fragmentation? Is it environmental objectives? Is it the movement or separation of ore versus waste, etc.? Because the ground in any mine is not consistent, is not uniform, it's continuously changing. From the previous, exactly, from that blast to that blast, it could be completely different. But do we, and we know what the answer to the question is, but do we accommodate those changes in the designs that we make? Or do we just go, tomorrow, do we just design the same as we did yesterday? It was good enough for my granddad, so therefore it's good enough for me.
Copy and paste.
Exactly.
She'll be right.
Exactly.
Right?
So that's yeah, exactly. So that's what we talk about when we talk about reconciliation. When we get a result today with a high with a blocky muck pile or a muck pile with a lot of fines, do we take the results of that and implement them into tomorrow's design
learn from it.
and learn from it, which is that feedback and control element.
Interesting.
And you've spoken about sort of trying to bring all these departments together and analysing all the data. Is this section of the mining moving towards that digitalisation, the use of AI tools to sort of investigate what he's doing and sort of help for the next thing, or is it still very much kept at, let's call it the human desk?
Yeah, there are technological or technical improvements available to us for modelling and measurement. I think that there's two challenges, or there might be more than two challenges, but the two challenges that come to mind are how well do we use them? And how well do we take the data from them to re-implement into tomorrow's blast? Again, this integrated management system. So while we have the technology, and this is another concern, we rely on a lot of these programs and technologies, but there might be a time when we over-rely on them and we don't actually know what's gone into them to really, as individuals, understand what is that science or what is the basics which went into developing them. Because it also means the more we rely on our computers means the less we rely on our minds, ChatGPT sort of syndrome.
Yeah.
Interesting. Yeah. I've got a question which is really not really part of the planned discussion, but do these things ever go missing?
What things?
The charges.
Well, they do. Yeah, they do. The explosives which these Zamazamas are using, they've come from somewhere. And the explosives which the ATM bombings are happening, they've come from somewhere.
Right.
There was one not long ago, I think in February, in the Northern Cape, and they managed to arrest the guys in Bucky and found
Mining
boxes
explosives.
full of explosives and detonators. And you don't just get these things from Checkers. They've come from either a mine or from the manufacturer or somewhere in between.
Interesting.
It's an interesting thought.
Yeah.
And it'll be interesting.
I was wondering what the rigor is in terms of, making sure that all the explosives that you bought or that you were supposed to blow in a blast today were actually detonated and haven't ended up on a bucky.
It's heavily regulated. It's heavily controlled. There are measures in place to reconcile what's been delivered to the mine, what's been taken from the mine magazines to the bench, and what has been returned. Now, of course, with every system or procedure, there can be ways around it.
Sure. Interesting.
Yeah, I actually never thought about it like that until you started talking, and all those who are from South Africa would understand exactly this, right?
Exactly.
And I'm pretty sure that happens everywhere.
Oh, it does. It's not just South Africa. It happens everywhere in the world. We just know more about it because we sit here.
So, in terms of the skills and your skill, are there more of Charleses out there that are actually consulting in this, helping to develop the next way forward in the industry? Or, and from an African perspective, how are we adequately dealing with this from an African perspective, maybe versus other places in the world?
Look, there are more of me, but they're all getting grey hair and moving into retirement. And typically the route into blast engineering or explosives engineering, whatever you want to call it, typically has come from mining engineering. And the pool for mining engineers and for processing engineers is getting smaller and smaller. It's not a sexy industry to be in. It's dirty and it's sweaty and nobody wants to do it. So the pool of mining engineers becomes smaller. And for instance, in the UK, when I graduated, there were 5 or 6 mining schools pumping out 100, 120 graduates a year. Now there's only one.
Wow.
They've all closed down. So if the pool of mining engineers is reducing, then therefore by definition the pool of explosives engineers is also becoming smaller
because it's a subset.
Yeah.
From a university perspective, do you think the education system is allowing young engineers to be able to, from early, identify that this could be a way to go? So do you think that maybe there's a gap in the educational systems globally that is starting to limit this pool, or is it just a facet of, well, as you say, it's not always seen as being a sexy role that you're out in the field and...
Yeah. Look, it's a difficult question to answer.
I wonder if it's not it's a general lack of visibility of the importance of mining.
Yeah, look, there's visibility. There's perception. Perception is that mining is not very politically correct. And it's a thing of the past. And for sustainability purposes, and we're all moving to renewable energies and such like. So there is that visibility. There's the perception. And I think, other industries are more attractive,
Quite
banking, insurance, whatever they might be.
Easier money.
Yeah, well, exactly. Yeah.
We've spoken about this a few times, and what most people don't realize is that 2 things are certain. It's either mined or it's farmed.
Yeah.
And that's really the 2 choices we have. So if you want to go into banking, which is great, that computer you have, pretty much everything out of that was mined to make that piece.
Exactly.
Yeah, and I haven't found any camera trees or microphone trees or...
No. So, we talk about it quite a lot with a lot of our guests.
Yeah.
Is really trying to get young school leavers, doesn't matter really where you are in the world, is that mining actually is sexy. There is a really cool part of this industry that is innovating and becoming special. You know, and in a dying art like your own, as you say, it's how do we start to create the next generation?
I think we need to get some videos from Charles of blasts.
Yeah, well,
and just loop it on this podcast. I love watching blasting videos.
Look, you know,
Who doesn't?
that's the sexiest part of it is watching these blast videos. But I think you know, from that visibility and aspect, the academic bodies, the universities. There's a lot which they can do, and there's a lot that they are doing. The mining companies themselves, they're pumping money into those universities to regrow that diminishing pool of engineering, mining or processing or whatever, or geology, whichever it is. You know, and I think that in certain aspects, explosives engineering, it's not traditionally been seen as a core production activity, and I think there's more that can be done, and I don't think the career paths have accommodated that. I think there's a lot of opportunity for mentorship by individuals like myself, by individuals, you know, in the corporates, and I think that if we're going to continue using these things which can't be grown, we have to continue mining them.
And we'll have to blast.
Yeah, exactly. Yeah.
As Trump says, it's, you know, drill baby drill, but in this case it'll be blast baby blast.
Yes, well, that's right. Yeah.
So no, it's an exciting period, and it's really quite interesting understanding, because you've, again, in preparation for today chatting with you, you know, we do a bit of work and research, and I really, what I believed and thought coming in, you really changed some of those perceptions of it's really a science and an art combined.
It is.
To be able to have something that is safe, done properly. And again, we've seen it on many a plant, and you hear the guys complain, you know, we're battling with run of mine and the ore, and there's some poor guy who's done a blast, you know, who's given too coarse a material, and everybody else downstream is crying. You know, where the next
and that might have been his sole objective: just break the rock and go home. You know, and, you know, and again back to that sort of integrated value chain, whereby what he does up there, what he does down there is understood by that guy up there, so that we can all work together for the common goal.
Yes.
And do people call you a pyromaniac?
They call me many things, but I've never been called that.
Seems like a cool title to me.
Pyromaniac, yeah. It's
What do you do at work today, Daddy?
I blew some stuff up. Yeah, yeah. No, my son's only 12, and because he's sort of in close proximity, he does find it sexy, and you know, and he talks about, no, I think I want to do what you do, Dad. But of course, I don't tell him the downsides of the, I had a really crappy day today. You know.
Yeah,
well, that's good. You're raising the next generation.
Yeah.
Yeah, and I think we're all lucky. I mean, we've all got young kids doing exactly the same, being very close to the coalface, as they always put it. So it's quite interesting to see. Obviously, going forward in the industry over the next couple of years, where do you think this industry, in terms of drill and blast, is actually going to go? Or where would you hope it goes?
Well, that's also a very difficult question to answer, because you can't get, as long as we're mining, you've got to drill and blast, you've got to process. Yeah. I think that one of the biggest challenges for the industry is that we're running out of these tacit skills that the grey-haired people have got, and they're not going to be around much longer to pass those skills on. And if they're not replaced soon, then there will be a gap. So I think that's the major challenge: is the skills, the availability of personnel, people who want to do the job. I think one of the upsides of the industry is some of these enhanced technologies, product technologies like electronic detonators, like drones, modeling and measurement technologies, which can assist the drill and blast engineer to do his job as long as he understands what has gone into this thing. And so it's really, you need both aspects, the human aspect and the technology aspect, married together for efficient execution. Otherwise, one without the other doesn't help anybody. You know, you might say to me, what's your view on digitalization? Well, it's great, but only if it improves your ability to make a decision.
Yeah.
If it doesn't, then big deal.
Yeah. So, to one of the cameras here, Charles has put a call out to interview young engineers, mining engineering, come and blow stuff up with Charles.
Yeah, it's sexy.
Yeah. Charles, thank you very much for coming in today.
Thank you very much.
You've now done your part in terms of shedding a bit of a light on an integral part of the mining industry, which is loosening up the rocks
Yeah.
in the first place before we even start conveying them or trucking them into a processing facility. So it's a pivotal production element of mining that we can't do without unless we're going to find, loose, free-flowing sand to mine everywhere. And so as long as there's hard rock and there's valuable minerals, critical minerals stuck in there, we're going to need some form of drilling and blasting, probably more and more and more.
Yeah.
And thank you for doing your part. And I urge you to, for the next 20 years that you've still got left, keep investing in the next generations, keep mentoring and have the patience to train more mining engineers like yourself.
Well, thank you very much for having me.
We want to share thank you to our sponsor of this episode, Africa Mining IQ. And to you, our listeners, thank you for joining us on the Mining Pulse. Don't miss a single beat of the industry's critical readout. Subscribe to the Mining Pulse now on YouTube, Spotify, or your favorite podcast platform. Please leave your comments as they help shape the conversations we're having right here on the Mining Pulse. Stay tuned for the next episode as we continue tracking the heartbeat of Africa's mining industry. Stay sharp, stay informed, stay on the pulse.